welcome Ashenafi Assefa from the Ethiopian Public Health Institute. He'll be speaking about Ethiopia assessment. It's actually a different title here. So Ashenafi, I'll let you introduce your title directly.
Okay. All right. Thank you very much. And I'm sorry to be the last presenter. I think it's not good to be the last presenter where everyone is hungry. So I'm going to present the utility of some of the tools developed to produce data that can be consumed by programs. So my title is Multiplex Serology shows cumulative prevalence and regional distribution of malaria in Ethiopia. As Epista introduced me, I am Ashenafi. I work for Ethiopian Public Health Institute, and I'm also a student at Addis Ababa University.
You can use
this one?
Yeah, use that and press arrows. Where did that go?
this one.
This one. Okay, thank you.
So this is the pointer, the laser pointer. This is going back and this is going forward.
Okay. So actually, Filsum has given some introduction for Ethiopian malaria situation, but malaria is still a public health problem in Ethiopia. Out of the 1.2 million square meters landmass, 60% is suitable for malaria transmission. In the country, areas which are less than 200 meters are considered malaria endemic, but we have malaria transmission sometimes up to 2300. So in 2050, we had 1.9 million confirmed malaria cases. I choose 2050 because it was the time of our data collection. So Plasmodium falciparum accounts for 64%, and the rest 36% were accounted for by Plasmodium vivax. We have some P. malariae and P. ovale, but there is no report on the magnitude of this transmission. So historically, in Ethiopia, there is malaria epidemics that occur between 5 and 8 years. The last epidemic that we have was in 2003 and 2004, where it cost us like 3,000 lives and 2 million cases were reported. Since then, the malaria program in the country has implemented a strong malaria control program with the following interventions, and there was no epidemics since then. This graph shows the decline of malaria in between 2001 and 2011. The graph in the left it shows confirmed malaria cases are declining, and the graph here it also shows malaria days. And as you can see, the year is around 2003 and 2004. So malaria indicator surveys is conducted to generate data again for the Ministry of Health that will provide timely information on malaria control at the national level. Ethiopia has conducted 3 malaria indicator surveys in 2001, 2011, and 2015. Among the objectives of malaria indicator survey is to measure the prevalence of fever, the prevalence of malaria parastemia, and anemia. So malaria indicator surveys they are representative multi-stage designs, and they give estimate nationally and sub-nationally. Areas which are above 2,500, those areas which are shown here in the white were excluded from the survey. But estimates are made nationally for rural and urban areas for altitude less than 2,000. And estimates also was made for all the regions. So estimates were made for the 9 regions that are shown here. So from the malaria indicator survey, we have this data, the prevalence data using RDT and microscopy. As you can see, prevalence of malaria using RDT was very low, using RDT 1.7%, 4.5%, and 1.2% using RDT. And this number was very low again using microscopy. It was like 0.9% and 1.3 and 0.5% using microscopy. So this may not show the actual magnitude of malaria, and it doesn't also show the transmission pattern. So we may need better tools in order to better estimate the malaria situation in the country. So we have used serological methods. As I've said, using conventional methods may be challenging in low transmission season, in low transmission settings like in Ethiopia. So serology may detect antimalarial antibodies over a person's life, or they may show cumulative prevalence. Again, serology has a greater utility in low transmission setting. Low seroprevalence or seroconversion rates may reflect the amount of exposure to malaria infection. Also, new methods like multiplex serology, they may help to detect several antibodies in one assay. So again, as probably everybody knows, malaria indicator survey is a cross-sectional household survey. We conduct malaria indicator survey in September and December, following the rainy season that starts from June and go up to August. So in this survey, we have surveyed something like 54,000 people that were in 555 enumeration areas and in 13,789 households. So in the survey, we have collected blood samples from all houses for under 5 children, but from every fourth house for all family members for logistic reason. So malaria blood spots was also collected during this time, in addition to malaria microscopy and RDT for molecular and serology works. So we had collected something like 15,000 DBS samples, but from these samples, around 9,800 DBS were available. Again, from these samples, 850 samples were failed during elution. Again, additional 39 samples, they miss demographic data. And again, some 678 samples also failed during experiments. So I'm going to report data for 8,227 samples. So in terms of methodology, we have used MACPIX instrument that you have seen it in the picture. So data was collected in multiplex. So what we do is antigens were coupled to magnetic pits according to the manufacturer's procedure. Bloods were eluted from the DBSs. Then the DBS elution was assayed for IgG antibodies. Data from this machine was generated as a median fluorescent intensity minus background from the instrument that you see here. So we have assayed several antibodies, but for now I'm going to report the response for these six antigens. So we have used MSP1 and AMA1 for P. falciparum, MSP1 and AMA1 for P. vivax. We have also included MSP1 and MSP1 for P. ovale and P. malariae. So for the data analysis, data was dichotomized to seropositivity using log transformed values. Data were fitted into component finite mixture model, and seropositivity cutoff was determined using these values, using the seronegative component and adding 3 standard deviations. For each individual, anyone who's positive for MSTP1 and AMA1 was considered P. falciparum positive or P. falciparum negative, and we consider it as ever positive. We also tried to feed the data into a reverse catalytic model to produce log profile likelihood plots that will help us to estimate seroconversion rates. Two potential forces of seroconversion rates were compared with single seroconversion rates for the model. So this is what we found in terms of seroprevalence. As you can see, we have for P. falciparum about 35.7% prevalence. That's ever positive. We have specific values actually. Then for Plasmodium vivax, again, we have 23.8% prevalence. You can compare it with the microscopy and RD data that I have shown earlier. So in terms of all Plasmodium cases, we have 45% prevalence. And as you also can see that we have good numbers for P. malariae and P. ovale, 7.2 and 2.6%, that they're not considered important in the country. So when we see the data from region point of view, we have very much variability of transmission in the regions. As you can see, in Gambela and Benishangul, these are the regions around here. These are suitable actually for malaria transmission. We have high falciparum and falciparum prevalence. And for P. vivax again, for Amhara, for Benishangul, Amhara and Benishangul shows high prevalence. And again, for the rare species, for P. ovale and malaria, as you can see, we have big numbers. They are also variable in the different regions. When we try to see the data in terms of elevation, again, lower elevations So lower elevations have high malaria, particularly for falciparum and vivax, compared to higher elevation, and it was statistically significant. We have also similar trend for the rare species, but it's not as such significant. It's not as such similar with P. falciparum and P. vivax. In terms of age, again, we have seen that response increases with age. It's actually expected because it shows exposure in lifetime. We have similar, again, increase of prevalence for the rare species, but again, it's not comparable with the main malaria parasites. So seroconversion curves, again, these graphs, they show that this is probability positivity, and this is age. So this graph shows that there is a decline of malaria transmission before and after 15 years. So this graph shows that the transmission was 0.42% or 42%, and it reduces to 0.29%. It is statistically significant. Similar trend was observed also for vivax malaria. All right, so we have also data for the regions, but unfortunately the regional data was not, there was some variability for the regional data. So seroconversion curves nationally, antibody positivity estimates showed significant transmission reduction for P. falciparum and P. vivax. Difference for estimated seroconversion rates were observed for P. falciparum and P. vivax. There was actually variability for the regions. So with this, we conclude that this study explored the malaria burden and intensity in Ethiopia using multiplex serology. Dynamic seroprevalence estimates were able to distinguish regional elevation and age exposure differences. We were also able to reconstruct historic exposure using seroconversion rates, showing significant change in malaria transmission over the past 2 decades. We were also able to identify potential P. malaria and P. ovale transmission. And this data generated may also help us baseline data for the ongoing malaria elimination in the country. So these are institutions to be acknowledged: my institute, Ethiopian Public Health Institute, the Federal Ministry of Health, U.S. President Malaria Initiative, CDC, ICAP, Addis Ababa University as my school, Mahidol, London School of Hygiene and Tropical Medicine, University of Southern Denmark, Addis Continental, Tulane, and Global Fund are acknowledged. Thank you so much.
Any questions? Great.
Hello, Imo Kleinschmidt, London School. Just maybe I missed it, but you showed that there was a significant change in the transmission, in the seroconversion rate at 15 years prior to your data collection. Was there any particular set of interventions or particular event that explains that change, or was it something more gradual, do you think?
Yes, actually, the strong intervention that I have mentioned has started in 2003 and 2004. So we believe that this is the result of that strong intervention that causes the reduction in rate of transmission.
All right. Well, thank you for coming. Thank you to those who had to stand. I want to thank all the presenters for sticking so closely to time, and also for facing some unexpected challenges, and especially David. Please, on your way out, spare a thought for David, who helped us with the presentations. Thank you.
Well done.